Okay, everybody. Just wanted to welcome everybody to the Food Production Solutions Association's Operation Series. This is a series on transitioning from legacy plant to smart factory. This is the second webinar in a series of five series. They happen every Wednesday, 2 p.m. Eastern through October 23rd. Some other topics we're actually doing is meeting increased demand with decreased labor force, data-driven maintenance as a margin enhancer, disaster prevention, and contingency planning for operations. So I just want to welcome everybody for this panel review. Just thought I'd give a little bit of an introduction to Gray Solutions. Gray Solutions is a system integrator. We do a lot of automation and controls. That's our primary, but we also do a lot with robotics and vision and all that kind of robotic vision, process engineering, IoT, OT, engineering. We're part of a bigger company called Gray Inc. But basically, what we do a lot of work in is we basically design and build large manufacturing facilities, mostly for the food and beverage. We actually do some other ones, but we pretty much focus on food and beverage. Gray Solutions, which I'm part of, basically does all the automation in those plants. We put in all the controls, the OT devices. We also enhance it with MES platforms, as well as all the automation and controls that goes along with it, especially in the area of robotics and vision. So that's Gray Solutions. I'm going to tell you a little bit about myself. I have one of the best titles, so VP of Cool Stuff, and there's a reason why I got this title. But I've been working with Gray Solutions for the past 5 years. I got about 30 years of manufacturing experience, really focusing on plant automation and innovation and any kind of process improvements. My title I got because I established what we call Advanced Automation Group, which is really kind of providing that cool technology, a lot with robotics, vision systems, AGVs and AMRs, digital twin. But I also do a lot with implementing some of the future emerging technologies such as AI and machine learning, a lot around advanced data analytics. But been with, like I said, Gray Solutions for the past 5 years. Prior to that, I worked for just a small consulting company called Accenture. I think you probably know them. I think they're about 800,000 employees now. So, but I really focus on industrial 4.0 practice and how we're, kind of getting into that space of smart factory. And, but I was part of that practice. I have a degree in computer science and mathematics and also an engineering degree. So that's a little bit about myself. I want to introduce Chad Ware. He's the director of industrial engineering for Epstein. So can you go ahead and Chad and give a description?
Yeah, absolutely. Thanks. Thanks, Greg. Yeah, as Greg said, I'm the director of industrial process engineering here at Epstein. If you're not familiar with Epstein, we're a 103-year-old AEC firm here in Chicago's West Loop. Myself, I've spent 30 years in manufacturing, 20 of those the past 2 decades in food and beverage manufacturing and plant design. And I work with Epstein's industrial clients to ensure that their new, expanded, and renovated facilities serve the processes that serve their customers.
So next, I wanted to introduce Jim Fortham. Why don't you go ahead and introduce yourself as well, Jim?
Whoops. Sure, thanks, Greg. So Jim Fortham, I'm the Senior Director of Control System Integration at CRB. CRB is an EPC firm doing all the various engineering disciplines as well as control system integration. So we, much like Greg said, we deliver the controls, the OT side, the whole part of it from an automation standpoint and instrumentation standpoint within the projects that we are working on. I have 30 plus years experience in control system integration. I spent 28 years with one of the largest integrators in the US and then came over to CRB about 3 years ago to help start up this group. So wide range of experience doing projects around the world. A lot of food and beverage. CRB also is big into the pharma life sciences side of the business. So we work on that side of the business as well. And then my past background is a lot of value-added ag and chemical processing as well. So,
Well, you could see a lot of
good, Greg.
some great experience from our panelists. So I just want to kind of talk a little bit about what we're going to be talking about today. You could see the panel. We have a ton of automation experience between the groups, the panel, but just really want to focus a lot in. So we all have a strong background in plant automation and engineering, but we want to discuss alternate paths to a smart factory future state. You know, those legacy plants, really driving them to that future state of manufacturing. So just want to mention, if you got some question and answers, please just, there's a little button where you can put in a question and answer, and we'll try to respond if it pertains, or we might hold off the discussion till later for a question and answer period. So feel free to do that as we go through some of these questions. Put some notes in your Q&A, and then we can discuss them later. So so that's it. I'm gonna go ahead and stop sharing, and then we're gonna proceed to go into some of the questions. So let's go to the first question we have. Oops, take me a minute to get to this. So I want to understand from the panel. So how do you define what a smart factory is? So just give me a kind of a general understanding of how that is. Chad, do you want to go ahead and talk a little bit about how you define smart factory?
I think I'll let Jim have a first stab at it here, and then I'll come in right after.
Okay. Okay. Thanks, Chad. Yeah. So from our perspective, a smart factory, is a facility that's fully automated and controlled. You don't have a lot of islands of automation. They may, legacy plants have islands of automation, but you're pulling those together into a comprehensive system, combining that so that you can share data between those independent systems as well as collect that data. And once you have that data collection, you can start doing more advanced analytics on it, looking at what's going on, doing some predictive maintenance. You can also use that data to inform operations and management on what they need to be doing within the facility to increase capacity or productivity, throughput efficiencies, things like that. And then the data models can also be used to pull into a advanced process control system, APC, or further down the road, get to autonomous operations where you really have a plant that, for the most part, can run by itself with very little operator interaction.
Lights out facility.
Exactly. Yep. There's a few of those we've done in the past, but it's few and far between, right?
Yeah, usually the cost kind of is a factor into a lot of those.
Absolutely. I don't know, Chad, if you want to add anything to what I said there.
Yeah, I mean, Jim's spot on. That's probably why I deferred to him as the expert in that first. But I think that it's also important for us to differentiate between a smart factory and a modern factory or a digital factory. Most modern factories do generate a lot of data, often in real time. Smart factories differentiate themselves by connecting that data to improve the end-to-end production processes, to help machine operators, line supervisors, engineers, executives, everybody on the team to make better decisions. And modern factories have been using robotics and automation for years. Not many of these facilities are accurately described as smart factories. We don't really apply that label until an operator makes use of an integrated system of machines to bring the physical and digital worlds together. So a smart food factory then is any food processing facility that uses a network of sensors and software and other technologies to monitor, adjust, improve their production processes, because they focus on outcomes and not only on the means. We can leverage the playbook of the smart factory to transform some of these aging food manufacturing facilities into something that's competitive with newer factories on yield, labor, quality, those sorts of things.
Excellent. No, that was good understanding. So, I mean, the question, I guess, is why move to a smart factory? What is the advantages of a smart factory, and what value does it get back to the business? So, some of the notable, I guess, improvements, I guess.
Yeah, that's a great question, Greg, because undertaking the monumental effort to transition an aging factory to an integrated, modern, intelligent manufacturing complex isn't something you want to undertake without establishing a clear set of objectives that everyone agrees on and that you'll measure your progress against every step of the way. Some of the broad areas that you'll want to discuss when setting those objectives include yield, throughput, labor, quality. I mean, you can ask yourself questions like, can we make use of data to make small adjustments to our processes that can result in higher yield? How will the new systems that I'm considering drive down my labor costs or improve the working conditions or help me retain talent better? And what will be the impact on the overall quality of the food products that we're making? Once you've considered those targets, you'll find some of the advantages, right? In addition, smart factories are going to harness data and analytics to drive real world manufacturing efficiencies. The technologies implemented along the way will be key enablers to things like remote monitoring of operations. They'll give decision makers direct line of visibility to operational performance. Machine vision and robotics capabilities support real-time process optimization. Those are real tools that feed great information to make those sorts of optimizations. And they can even sometimes allow a remote operator to change the product mix on the fly, match the finished goods inventory to the order backlog, like by magic or something. We'll talk more about it in a little bit, but a well-organized and connected smart factory sets the stage for the creation of digital twins in the production environment, the virtual factory, if you will, that acts like a sandbox where the operations team can test different production strategies and process flows without committing the capital, time, or taking the risk associated with testing those scenarios in the real world. The potential benefits, depending on the exact implementation and the goals of the user, go on and on. But they go from everything like increased throughput, decreased operating costs, decreased labor costs, improving safety, reliability, flexibility. It goes across the gamut.
So there's some pretty good ROI when you look at some of these solutions. I mean, because it is an investment. It's an investment from the company to invest in the smart factory, but there are some great outcomes to that can achieve that. I like your point about the digital twin, really kind of looking at things prior to huge investment. I think companies go into that just with that, I guess, really huge amount of money into this facility when maybe just doing a proof of concept or maybe doing just a smaller entry into that segment is a great way to do that. So
yeah, simulation and the digital twin. Sorry,
yeah.
Go ahead, Jim.
I was just going to jump in and say I agree. What you said there, Chad. There's a lot of benefits to it. The human side, making somebody's life easier. The workers you have there, so it's not so mundane or repetitive where there's a chance of injury. Risk of injury is a big deal. That drives costs down completely when you don't have work comp issues or people out when they can't work if they're injured. So there's a big part of that. Also with the reduced labor cost, if you're in an area where there's a strain on the labor pool already, or if there's a small labor pool, that really makes a difference when you have that automation that can fill in some of those gaps. It's not necessarily replacing workers with automation, but it's more supplementing that when you can't find the workers. Where I'm at up here in the Midwest, we have a lot of land with not a lot of people sometimes, and so trying to find those workers for these facilities can be a challenge sometimes when we're building these areas. And so we've seen a big push on the automation side. That's one of those, what I see as real advantages. We've done some centralized monitoring and control of multiple facilities from one location. So that benefits the client because they have one group of operators basically running 2 or 3 facilities versus 3 sets of operators in 3 facilities. So there's big advantages to being able to do that.
Yeah, and I just think, when you get into robotics and some of those areas, it's really taking up those repetitive jobs or the jobs that are really, it could even be a safety thing. I mean, heavy lifting, things like that. So I think that's a great way to look at the benefits. So the benefits aren't all, financially driven, but safety, so I think
Yep.
that is a key to that. So
Yeah. How many plants have you been in where they're dumping 50-pound bags
I
into a
know.
mixer, right?
Yeah.
Manually. If you got robotics to do that, you're saving that operator's back or whatever it may be. That's a benefit that's hard to measure.
And even in the vision systems, when you're looking at some of that, I mean, visions has come a long ways. We look at our smartphone now. I mean, the cameras on them are just amazing now. I went in a plant and I was able to do a 3D imaging of a piece of equipment using my iPhone, which is something you couldn't do. So the vision systems have grown quite a bit. So it's been amazing what they've been able to do. Now, when you look at this, and what are some of the challenges companies are facing transitioning to the smart factory?
So there's quite a few challenges. They're kind of the flip side to what the advantages are. CRB recently did a survey of over 300 food and beverage clients, talking about digitization and automation in food facilities, and what is one of the questions, what is the challenge to doing this? What's holding people back? And so it was very interesting to see that data come back. So like initial cost of improvement is one of the big ones, and this was a multi-choice question, right? So like 44% of the respondents said the initial cost is what holds them back from doing it. Trying to get that investment in the equipment, the infrastructure, all those kinds of things go into that. Risk management. What's the risk of doing this versus the way they've always done it? A lot of these are legacy plants that have legacy processes, so they're used to doing it the way they do it. And if you start automating that, what is the risk involved with that? Um, Another one, and a big one you hear about a lot, is security and cybersecurity concerns. You hear quite a bit about people getting held hostage or people stealing their data, not just in a food plant, but just in general. How many times do you get notifications that, hey, your data was maybe compromised because somebody broke into Target's database or whoever it is, right? Um, there's a fair amount of organizational reluctance that we see too. You get in, and again, organizations, especially at an operations level to a certain extent, feel like they are losing control of how they process and make a product if it's being done automatically. They're maybe not as involved in the decision sometimes, and so they feel and push back on what we're trying to do until you really sit down and explain the benefits and what other information they can get and how it frees them up to use the resources they have in a different way. If you have operators that you can now, instead of lifting 50-pound bags all day, use them to do something else that's more value driven, that's another benefit. So having that conversation with what that looks like, with automation and the smart factory initiatives that are going on, there's also a different skill set required. You've got to have a little bit more well-trained people, a little bit higher up on their knowledge and education, things like that sometimes, to be able to support and service the systems that are being put in place. Again, though, that's really an upskill of an employee, which is a benefit to that employee. You also aren't replacing 4 line workers with 4 skilled people potentially. As you move them up and reuse those skill sets elsewhere, you're not replacing one for one necessarily when you automate and need a more qualified person. But that's one that we do a lot of background on, as well as what's that skill set required, who do they have on staff today, or where can they get that skill set to help them understand how to move forward in this process. Another one is just availability and testing of the technology that's out there, as well as confusion about what's in the marketplace today and being offered. You hear a lot about AI or machine learning. Well, what's that really mean? It means something different to me probably than it means to Greg or it means to Chad or anybody else on this phone call. There's a whole different spectrum of how you look at that and what that means. So that confusion also means people are slower to want to transition because they don't really know how to transition and what it takes. So and then, the last big nugget that we got from that survey we did is the um, understanding of data management. Like Chad said, you're going to start pulling a whole bunch more data as you start to automate and the advantages of it, but you have to be able to do something with that data. Just collecting data and having data in a database or a data repository and not using that to make decisions and drive forward has no value. It just means you got a bunch of data. I mean, so that's kind of a lot of what we see the challenges that we work with our clients when they're trying to transition to a smart factory.
You mentioned, some of the foundation that they're missing, and I know they have to do I see a lot on the, infrastructure as a key, and that's your building block. So that investment needs to happen. And I
Right.
think they're hesitant, but that's your foundation. If you don't have a good foundation, then you can't build the good factory. So, how do we, how can we tell customers what a good approach is uh, to basically transitioning to the small factory? What's a good way for them, and where should they start off, or how should they do this?
So what we do is try to sit down with them and let's talk about philosophy first. What does it mean to them to be a smart factory in 2 years, 5 years, 10 years? So we kind of get that bigger picture. Because like you said, Greg, having an infrastructure in place is key. Put it in now, even if you're not fully utilizing the whole infrastructure, but then you're set up to put those building blocks on top of it. Because without that infrastructure, you're going to continually be trying to expand that infrastructure, and if you didn't plan for it up front, it just doesn't work out well. So that's one of the big things is what is that philosophy, and then really building a plan. What does it look like? How are we going to get from step to step? What are those milestones that we can measure and report against to see how we're doing? How's our progress coming? And what does it look like? And are we getting the ROI that we thought we'd get? So basically kind of stage gates along the way so that we know we're on target for where we want to go and we're making progress like we should. I think those are a couple of big ones, from our perspective that we try to get early is what that looks like.
Yeah, I know we try to drive a lot of proof of concepts. Let's see what we can do at first,
Yep.
and and I also like to see where the business maybe needs some value and focus on trying to deliver some immediate results or some benefits immediately versus a long term. So I think the kind of unique approach in solving those business problems, but really have a overall plan, but then take that plan and kind of dissect it into smaller chunks that maybe can accomplish quicker. So you mentioned Jim a lot on this, I guess, this emerging technologies. So you guys tell me a little bit about this, and how is this emerging technology affecting the AI and ML? I just hear this stuff all the time. So how is it affecting that smart factory concept, and what are some use cases for that?
Yeah, I mean, you touched on it a little bit there, and you're right. You can't go anywhere these days without running into a discussion of artificial intelligence or machine learning, depending on who you're talking to. It's on everybody's mind. So it's really no surprise that it includes the thought leaders in the food processing industry. Many of us probably understand there's an inherent limitation to the experience flexibility of any factory, including a smart food factory, when all of the variables have to be contemplated, organized, and optimized in the beginning into a finite number of recipes or product combinations. You're trying to take in all the information at first and then write some sort of plant automation system that considers everything and produces every possible outcome. The most immediate path to an operational gain in food production leveraging AI is to actively manage your product mix, right? So don't lock yourself into those few recipes or product combinations that you were able to think of ahead of time, but actively learn how the small actions you take in your plant are turning into a finished product inventory that either does or doesn't meet your sales needs, right? And that's, at the end of the day, that's matching those two to each other is the most important thing. So AI will allow you to actively manage your product mix based on factors like incoming product quality, ingredients and machine availability, what the work in progress levels are, and the availability of downstream packaging equipment and so on. When all the variables are known and the current conditions can be compared to historical performance in real time, there's a real opportunity to actively manage our production through machine learning algorithms. You know, one real world use case that I know of that's in trials today is a system that actively manages the end products being created by an automatic poultry cut up and deboning system using information gathered through multi-length wavelength vision grading systems, so not just RGB, but also using near infrared, aggregated plot weight and health information, and then feed that all into AI. It compares it to the historical data together with the current order information, applies a variable logic decision-making progress, and then tries to determine what the highest value and product mix is from this flock of poultry moving through. So that's really interesting, and you can apply that. It doesn't have to just be for the poultry industry. You can imagine you could apply that a lot of different places, and that's those. There are companies out there actively testing solutions right now. I think the second most interesting use for artificial intelligence in food processing, in my opinion, is to improve the quality of our predictive maintenance. The idea here is to feed the machine learning model data related to equipment uptime, motor amp draw, machine performance, and then allow the model to learn the indicators that the equipment and its systems are at risk of failure. AI systems can reverse engineer failures to look for common indicators that equipment downtime may be imminent. You know, predictive maintenance AI systems can act a lot like having the eyes and ears of an experienced maintenance tech sitting on the floor 24 hours a day, watching every piece of equipment.
Yeah, you mentioned vision. I do see a lot of vision. You know, vision's been around for a long time, and AI's been incorporated in that a long. It's not new to that. So I know we use a lot of vision systems. We implement a lot of them, and they're always constantly learning based on the number of imaging. It's actually, so you start to see all these pictures. The more data it gets fed, the more learning it can do. So yeah, vision, I definitely see that as something that we've already made some pretty big strides on already in most facilities. And but when you look at some of there's other opportunities I definitely see where, the maintenance aspects of it. We actually looked at a solution even around listening for you look at vibrations of motors, but even the noise that motors make, could be enough to say, maybe I need to do some PM on this work on this because it sounds like it's going to be. And that's some of the things that that we've been challenged to do. And you're probably finding a lot of those examples as well. So
yeah, there's definitely some things to do with that. We like you mentioned, acoustical sensing, we've done some of that like on steam traps, where you can actually put an acoustical sensor, train it, and start looking at the trending and apply that with preventive maintenance so that as that trend changes, what's going on with that steam trap if it's starting to leak. There's a lot of the sensors that we install, bearing monitoring, vibration, like you mentioned, that as you start collecting that data, you can see a trend and then start analyzing when you need predictive maintenance before the piece of equipment fails versus, always doing it after the failure. So there's a lot of those sensors now that you can tie in and really utilize that data. But again, you've got to have a data plan of what you're going to do with that data, not just collect it. So.
I think
Yeah.
it's a challenge getting that much data and really taking
Yeah.
in a lot of the data. Some of the data needs to be cleansed before you can make it's not necessarily that clean. So you got to decipher a
Right.
little bit. So yeah, I think taking the data to put together plans and execution on that data is a
Mhm.
key. Um,
Right.
I wanted to talk a little bit about, we do a lot with robotics and cobots and things like that, and that's becoming a pretty big, and usually if you look at plants, they have a lot of, in the palletizing, for example, you probably have a robot there or something like that. But I see that robots and cobots are becoming more mainstream in other areas. Can you guys elaborate a little bit on some of that technology that's going out in those manufacturing facilities?
I don't know if Chad, if you want to touch that one first, or
Sure. I mean, we see them all over the place, right? But a lot of it are to do with heavy or repetitive tasks. And so that doesn't only have to be, I mean, obviously, like you already mentioned, end of line packaging. End of line packaging makes a lot of sense, right? Because you
Yeah.
have a uniform thing that is heavy and repetitive. It's a perfect place to throw a robot in, but they're expanding. And together with the vision technologies that we were talking about earlier, you're able to use them for more and more things like advanced cutting, any repetitive motion task. And like you said, cobots then that are able to assist a person where you
Yeah.
have that mental acuity of the individual together with the never give up attitude of the robot.
I think too, you know, what you're seeing for autonomous warehouse management systems and the autonomous vehicles and quote unquote robots in there too, right? That's that's a big application for them as well.
So I think we got some case studies I wanted to present. I is it a good time to go ahead and present some of these? I think we have a
Yeah,
few case studies I wouldn't mind presenting. So let me get to that.
I think it's always good to have some real world practical application to talk about. So
So I got this first case study, um, Holston Farms plant. Can we talk a little bit about this one?
I'm talking specifically about updating aging plants. And I commented earlier about the importance of aligning smart factory capabilities with the business and operational objectives of the owners. Holstone Farms is the processing arm of a farmers collective raising hogs across the Midwest. In 2018, they brought Epstein an interesting problem. They were looking for help developing a master plan to transform an aging Hormel pork processing facility in Fremont, Nebraska, into a state-of-the-art connected smart factory that could operate on a level playing field with the most modern greenfield protein harvesting operations. They came to the table with a clear set of objectives, right? They wanted to increase their production volume from 8,000 head per day to 23,000 per day. They wanted their end product quality to rival what they saw coming out of larger and more modern plants. They quantified improvement targets in yield, efficiency, product flow, all things they needed to achieve. And they wanted to provide their employees with an environment where they could be comfortable, proud, and most importantly, safe. And they wanted to do all this, of course, with minimal disruption to their existing plant operations. This is one of the real advantages, I think, of converting a legacy plant to a future-proof smart plant. For all the challenges that come from working around an operating plant and implementing new technologies in a location that may not have been designed with the infrastructure required for a modern system, here's the real advantage, right? Revitalizing an existing plant allows the owner to keep generating revenue while they invest capital in a brighter tomorrow. So how did Epstein and Holstone approach the problem? We started by generating some preliminary designs and budgets to help the client make informed decisions about where it's best to invest their money. Where should they build new? Where should they reuse things that were already in there today. In the photo on the top here, you can see all the new and renovated areas in orange that we propose to overhaul as part of a multi-year 10-project master plan that Epstein submitted to the client. We broke ground on the first project in 2018 and turned over the keys to the last building just last year in 2023. Construction wasn't entirely without difficulties. You know, it's challenging to operate a full-scale construction operation adjacent to an operating GMP food process. You can't just cut off the electricity to connect a new building when the same service is feeding the existing equipment. And while it's a huge advantage to have the opportunity to transition your staff directly into the new facility, workers do need time to adjust changes in their new working environment. And we're not always sure what structural or utility connections we're going to find when we crack open an existing building. But if you can manage all these challenges, there's a lot to be gained from doing a conversion instead of a new build. You know, Holstone was able to implement a number of smart improvements, including self-cleaning features for the building and for the equipment, the implementation of automated CO2 stunning, a more linear process flow, a modern utility system with digital feedback and data collection, line control systems, vision systems, and vision-guided robotic cutting systems that we were just talking about that provide really accurate and repeatable. Some of the benefits that Holstone realized at the end of the 5-year design and construction effort included the continuous operation of the plant through the whole thing. The new plant has the same labor force, the same management, the same service providers as the old plant. And because of that fact, they saved tens of millions in dollars in startup costs versus what Greenfield would have had. On a Greenfield project, you know, working capital we see can be between 25 and 30% of the capital investment. With a legacy plant conversion, training and the startup costs, without lost orders or lost efficiency, the working capital may only be 1 or 2% of the total pie. And the staff ended up with a great working environment that's much more open, flexible, modern, comfortable. The workers are happier, and happy workers miss less work, jump ship less often, and are generally just more productive. When Epstein and Holstone started up the cut floor, one of the last areas in the new facility that came online, the ramp up to full production was smooth, fast, nearly seamless. You know, it's a key competitive advantage to see for an owner who decides to revitalize their current operation instead of, you know, tossing the baby and the bathwater out together. The next slide, if you want to look really quick, Greg, is just a couple of before and after photos. We won't. Yeah, you just can here. You can kind of see the old cut floor and the new cut floor, much more open, a lot more headroom, a lot better lighting, better access to work areas. The old edifice of the building, the new edifice, and even the locker rooms. You know, we made a big improvement in employee welfare areas as well. So.
That sounds like an amazing opportunity, Chad. I just, yeah, I love to see that. Yeah, it's always a challenge when you're going into I mean, they're running and you're trying to update them or upgrade those. I know I have a few customers right now. We're working on projects and we got to try to transition that because they run 7x24 pretty much. And they want to do a bunch of, so it's always pretty difficult, but it sounds like that project went pretty successful. Yeah,
it was a great project.
I wanted to talk about a project, and we actually did, this was a pet food plant, but we went into this this customer, they wanted a new pet food plant. The other pet food plant was pretty old, so they wanted to build a brand new one. And right off the bat, they said they wanted this to be a smart factory. So it was kind of our neat approach we did. We basically sat down in all the different areas, workshops, really focusing on all the aspects of an operations at a facility, logistics, maintenance, quality, production. And basically we're put together kind of workshops to say, it's almost like you would want to say, if we're Santa Claus, what would you want to see for this new factory? So what is that? future stuff. So we really focus on not what they had now, but where they wanted to be. So it's a great approach. And some of the results were, it was amazing, Bill, but we were able to add in a lot of those smart factory add-ins. So we actually built a digital twin for them. It was pretty amazing. We built the whole process before the plant was even built. So they were able to see that facility running in, it was more simulation mode, but they could actually see their entire plant running. We added a lot of emerging technology. So this plant has a lot of robots, vision. We got AMRs going around. We implemented just some pretty interesting technology. We actually did a lot with their data collection and digitalize and everything. They basically said, we want a paperless process. So basically we digitalize almost everything. So pretty amazing facility, but our kind of approach was unique of how we did that and really getting them on board. So bringing all these business people together, they became part of the solution. I think that was an important concept. So if they wanted to see that future, they were part of the process. So I think it's kind of an important thing to um, to bring in. So I think we got a few more questions. I'm going to stop sharing. Um, we had a few more questions. I want to make sure that I've covered everything on this. So let me get back to it. We talk a little bit of approach. I think we still got time. I want to stop this and make sure we can, but how are we gonna, what's the best path that we provide to our customers on this smart factory path? What were some of the, I guess, how do we approach this with them? What's the best way, or what would we recommend?
I think we touched on it a little bit on a couple of, the advantages, disadvantages, and how we get there. But that whole having a plan and strategy where you want to go. If you have the resources to develop it internally, or if you need a trusted partner to work with to help develop that plan, it is really the first thing we see as a key. And we've worked with clients both ways or hybrid, where it's both an internal and external team working on it together. Once you get there, you mentioned proof of concept, Greg. Doing something small, make sure it's going to work like we expect it to work before you try to roll it out into a larger scale in the facility. There's, on the life sciences side, they have the digital plant maturity model, they call it. And there's also something similar that a lot of the food and beverage guys use, right? And knowing where is your plant today on that model, so you know kind of where you need to go to get there. It gives you kind of a guideline of what it looks like when you're taking those steps to get more automated as you go along. Because there's very, very manual to fully automated, and that helps you see that vision of where you want to go and where you really are at today. I don't want to capitalize on all this chat if you got some stuff.
No, I think that's great. I mean, yep. I'd mimic what you say and just add, understand what you're trying to achieve. I may sound like a broken record, but it's critical to understand the why before you even start to talk about the how and the what. In addition, you say start small, pilot it. I agree with all of that. If all you have is data and infrastructure, then start there. Create a digital sandbox and test some ideas for improvement. Identify the most robust improvements and start there. Check your pilot plant against a real world outcome of the simulation and compare that to the simulation. What planned out? What didn't? Improve your model. Try again. It's like what they say about eating an elephant. It happens one bite at a time. Maybe just don't start with it.
Yeah, yeah. Go ahead, Jim.
As I think too, as you go through that, you have to figure out what are your must-haves versus your nice-to-haves, right? Everybody wants the nice-to-haves, or the wants, and they'll call it needs, but it's not really needs, it's wants, right? Yep. You need certain things, and there's certain things you just want because it's nice. So if you can keep that kind of as a guiding light too of what's really a need versus a want. That helps a lot too, because you can easily scope yourself out of ever being able to justify doing something like this.
Yeah, I think that's a great, Jim, that's perfect because I think a lot of times, companies are looking at, a technology aspect of it, and they focus on the technology, implementing the technology. It should
Mhm.
be, let's look at the business case we need to solve for, and let's take technology to solve it. I know I remember some plant managers, they would see some cool stuff at a show and they say we need to implement that, and I goes, well, what's it going to solve? So you really got to solve a business case, so it's important. So um no, I think this was great, Jim, Chad. This was amazing. Just got a lot of information out of it. um do we have any question or answer questions from anybody? I don't see anything post in the chat, but I think I maybe you guys just answered everything, Chad. Maybe you guys were just right on, so maybe there wasn't a reason why any questions. But I think it was worthwhile. I just want to tell everybody that's on this that this will be available on FBSA's YouTube channel the next day. So I encourage you guys to go ahead and watch this. And I think there's an upcoming one too. There's a few of those. Like we mentioned, they have them every I think it was every Tuesday. Yeah, every Tuesday they have
Wednesday.
Every
Wednesday.
Wednesday,
Sorry,
every
Wednesday,
Wednesday.
2 p.m. Gotcha. So there's some neat topics. Actually, I'm going to be doing the one on decreased labor force. So I'll be on that one. So I appreciate everyone's time. Jim, Chad, I really appreciate it. It's been fantastic. And I think it's a wrap. We don't have any more questions. Appreciate it.
Thank you, everyone.
Thanks for getting us along, Greg.
Hey, not a problem. Talk to you guys later.
Thanks all.